Today we're doing section 2.2, graphing quadratic functions, and we're going to focus on graphing in standard form. So, standard form of a quadratic function looks like f of x equals, and remember that f of x could be a y, just depends, equals a times the quantity of x minus h squared plus k. I'm sorry, I'm looking at this. This textbook calls this standard form, but this is actually, I would call this vertex form, and this is the vocab that we used last year for it. So I would refer to this as vertex form, not standard form. I'm not sure why the book is calling that standard form. So there's a four-step process to obtaining the information that we need to graph it. So first we need to determine if it opens up or down, and your a value will determine that. So if your a value is positive, it opens up. If a is negative, it opens down. Your vertex is HK, and this is again something you might remember from last year. Notice it's the opposite sign of the inside number and the same as the outside number. Your x-intercepts, to obtain them, you set your function equal to 0 and solve. Your y-intercept, you evaluate the function at 0. And then once we have all this information, we can create the picture. We know our axis of symmetry will go through the x part of your vertex. So in this case, your axis of symmetry is happening at your h value. So let's go through an example. We'll obtain all the information, and then we'll create the picture out of it. So for our first example, we are doing f of x equals -2 times the quantity of x minus 3 squared plus 8. So we're just going to go through and write down all the information that you'd have to find. So first we would say that this parabola is opening down because your a value equals -2. Then we're going to obtain our vertex, and our vertex is a +3 and a +8. Again, notice it's the opposite of that inside number, the same as the outside number. To find our x-intercepts, we set our function equal to 0. So I'm going to say -2 times the quantity of x minus 3 squared plus 8 equal to 0. And we need to solve. So instead of multiplying this out and foiling, the better direct method is to use the square root method. So I need to isolate this quantity as much as possible. So I'll start by subtracting 8. And after I subtracted 8, I'm now going to divide both sides by -2. So now I'm at x minus 3 squared equals 4. And to get rid of that squared, we introduce the square root to both sides. On the left-hand side, I'm left with x minus 3. The square root of 4 is a plus or minus 2. So there's my two answers that I get. And to get x by itself, I need to add 3 to both sides. So to obtain these two answers, I'm technically doing 3 plus or minus 2. So 3 plus 2 I get is 5. And 3 minus 2 is 1. So there are my two x-intercepts. And the last thing I need is my y-intercept. So to find my y-intercept, I evaluate the function at 0. So I plug 0 in. So I have -2 times the quantity of 0 minus 3 squared plus 8. So 0 minus 3 is -3. We need to follow our order operations here, so I need to square it first, so that will become 9. Then I do multiplication, which is -18. And when I add these together, I get -10. So this is my y-intercept. So the last thing that we need to do is get this information on a graph. So I'm going to change the screens for a moment just so I can get all this information onto a graph. So here's all the information, and now we just need to create our picture. So I know that the parabola is opening down, so this is more just as kind of like a check for yourself to make sure your picture matches your work. So I'm going to plot my vertex, so I'm going to go over 3 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. My x-intercepts are a positive 1 and a 5. My y-intercept is negative 10. And I know that the axis of symmetry goes through the x part of my vertex, so my axis of symmetry is right here, which means I have enough information to create one other point, so I know that all these points are symmetric. So notice your x-intercepts are 2 units away from that symmetry, so your y-intercept is 3 units away, so I can determine that another point on my graph would be a 6 and a negative 10. So at this point, I now have enough information to create my parabola. So let's, actually we'll do one more just obtaining the information, and then we'll create the picture. So this problem is f of x equals negative, nope, sorry, wrong problem, equals the quantity of x plus 3 squared plus 1. And we'll run through this problem relatively quickly. So a is 1, so I know my parabola is opening up. My vertex is a negative 3, 1. So my x-intercepts, we're going to set this equal to 0. So I have x plus 3 squared plus 1 equals 0. So I'm going to subtract 1 from both sides. And here, at this point, I'm going to take the square root of both sides. So I get x plus 3 equals plus or minus I. And then I subtract 3 over, so x equals negative 3 plus or minus I. So this means my x-intercepts are imaginary, and when we go to do the picture, I'll kind of reiterate what that means. And my y-intercept, I evaluate it at 0, so I have 0 plus 3 squared plus 1. So 0 plus 3 is 3, 3 squared is 9, plus 1 is 10. So now we're going to take all this information and get it on our graph. So I can plot my vertex of negative 3, 1. And I can't plot my x-intercepts because they're imaginary. I can plot my y-intercept of 10. 9, 10. I know my axis of symmetry is happening right here, going through the x part of the axis, so I can determine this is 3 units away, so I need another dot 3 units away. So something we had discussed last year is if your function is not crossing the x-axis, that's why we get this idea of imaginary or complex solution. So this is why our x-intercepts are imaginary. So that's all for today. We will do some practice on this tomorrow.